Hi, in this video, we're going to look at how we tackle exponential equations with single prime bases. Here we have a to the power of x is equal to a squared, and we need to solve for x. Our bases are both a, so in order to make these terms equal, the exponents have to be equal as well. Here, our exponent is 2, so the only way for a to the power of x to be equal to a squared is if x is equal to 2. From this, we can see that if the bases are the same, then the exponents must be the same as well. And we're going to use this idea to solve for x in our exponential equations. Let's look at the example 3 to the power of x is equal to 9. To tackle this question, we need to give both sides the same prime base. We can use the base of the term with the unknown exponent as a guide. So in this case, 3 is our base. So on the left, let's say 3 to the x is equal to, and on the right, we know that 9 is actually 3 squared. So I can say 3 squared. We have a base of 3 and a base of 3, which means that x will be equal to 2. So we say x is equal to 2. Let's do another one. Here we have 2 to the power of x is equal to 32. Let's change 32 into a prime base. And from our experience with exponents, we know that 32 is actually 2 to the power of 5. So I can say 2 with an exponent of x is equal to 2 with an exponent of 5. Our bases are the same, which means our exponents are the same. And we can say x is equal to 5. Now we have 2 to the power of x is equal to 1. We cannot change 1 to a prime base of 2. So what do? The rules for exponents taught us that any value with an exponent of 0 gives us an answer of 1. So in this case, we can change 1 to 2 to the power of 0. Because remember that anything with an exponent of 0 is equal to 1. Here we have a base 2, so we can say 2 to the power of x is equal to a base 2. And the only way to make 2 equal to 1 is give it an exponent of 0. Now we've got base 2 and base 2, which means our exponents are equal. So x is equal to 0. Here we have is 3 to the power of x and 5 to the power of x. They are both prime bases, but they are different bases. So what do we do now? We have just said that any base with an exponent of 0 gives us an answer of 1. So the only way for this equation to be true is if x is equal to 0. So I can say x will be equal to 0. Please remember that if you have two single terms with different bases, the exponents will always be 0. Let's do one more example. Here we have 2 to the power of x over 2 is equal to 0,125. This is a decimal. It's not easy to work with. So the first thing we need to do is change the decimal into a fraction. On the left side, we have got 2 to the power of x over 2 is equal to 0,125 is actually 125 over 1,000. And if we simplify it, we'll see that we get 1 over 8. Now we need to change 1 over 8 into prime base. So on the left, we have 2 with an exponent of x over 2. From our experience with exponents, we know that 8 can be written as 2 to the power of 3. We have 1 over 8, so we can say 1 over 2 to the power of 3. But we don't want fractions. Fractions make things a lot more difficult. So let's get rid of this fraction over here. So we can say 2 to the power of x over 2 is equal to get rid of the fraction, we're going to move the denominator to the numerator, and we make the exponent negative. And we get 2 with an exponent of negative 3. Now we have a base of 2 and a base of 2, which means our exponents must be equal. So we can see that x over 2 will be equal to negative 3. Now our last step to solve for x is to get rid of this 2 over here. So all we have to do is multiply both sides by 2. And we see that x is equal to negative 6. Please work through some examples in this section before continuing with our videos.